Okay, so this is section 8.6, and in this section you need to be able to determine what factoring method is going to be best for you. And there's a few steps that you can take to be able to determine that. You should have written them on the top of your homework for this section, but at the same time this whole video should give you a couple more ideas about what you can do. Now, the ultimate question is, how do you know when you've done all the factoring you can do? I'll add that. How do you know that that is the case? Well, through all of these steps, we can look at that. So how do you know if you've done all the factoring you can do? Well, one of the things that you can always look at is, do you have any terms, any GCF, any greatest common factor in each and every one of the terms? If I look at this, I mainly want to focus on this section. I mainly want to focus on these terms, x squared and 4. Mainly because they're inside parentheses. That means a greatest common factor has already been taken out of them. If there's anything else that is in these two terms, it should show up. And x squared plus 4, it almost looks like a difference of squares, but the thing is about difference of squares, this needs to be a subtraction sign. And since it isn't, it's not going to factor well. So we have 2x times x squared plus 4, and it doesn't look like there's any GCF. There's no other factoring we can do because there's no other difference of squares. We could try bottoms up, but at the same time, because this is a plus sign, it's not going to work out well. So it looks like we're about done. So I said before, there's a couple of steps that you can take to see if you have everything taken care of. Well, our first step 1, find and factor out the greatest common factor. After that, you can then identify perfect square trinomials or difference of squares. And this is one that's kind of hard to see. So if you don't see the difference of squares, or if you don't see the perfect square trinomial, then you can actually go to step 3 and you can factor it. And you can use the bottoms up technique, you can use guess and check, you can use whatever technique you've been working on and what works for you. And then lastly, look for any other common factors. It's a possibility that when you were factoring initially with step 1 that you didn't take out the full greatest common factor. And if you didn't do that, then it's going to be kind of hard to finish it up. But you can finish it up in step 4 by looking for any more common factors. So let's start with this first problem. We have negative 2xy squared plus 16xy minus 32y. Now, step 1 tells me I need to look for greatest common factor, and I can see in each term there's an x. Or, what? Not each term, there's not an x. No, there should be an x. Oh, yeah, there should be an x in every single term. Sorry. That should have an x in it. Each term there's an x. As well, in each term there should be a negative 2, which I could probably take out. And if you only saw that there was a positive 2, you would take out the positive 2x, and you'd end up finding that factoring is a little difficult, and it's a little more difficult than normal. So if you take out that negative, because you always want to have this first term, if possible, be a positive number. If it's a positive number, it's a lot easier to deal with. But if you can't do that, you can't do that. That's just how it goes. So let's say our greatest common factor is a negative 2x. That is our GCF. So if we were to take that out, a negative 2x, we end up with y squared minus 8y plus 16. And actually, this is what is going on. I shouldn't have a second y here. I screwed up my initial video. Sorry, guys. I apologize. Stick with me. You'll see on the other videos that it's not quite as bad, or on the other examples, it's not quite as bad. So now we have negative 2x times y squared minus 8y plus 16. And from our original equation, we now need to see if we can factor this. Step 2 tells us to look for perfect square trinomials or difference of squares, and it's definitely not a difference of squares, and mainly because there is a middle term there. Because of that middle term, we're only looking at perfect square trinomials. And if I think about perfect square trinomials, I need to be able to break this up into 2 perfect squares and break this up here into 2 perfect squares. And then my middle term needs to be essentially the multiplication of my a and b terms, so a term, b term. And that's exactly what it is. So I can rewrite this as negative 2, oops, not that, negative 2x times y, sorry, I'm making mistakes all over the place. Y minus 4 times y minus 4, or I could rewrite that as negative 2x times y minus 4 squared. After that, we need to see if there's any other factoring we can do. I don't see any other factoring we can do. It's totally set up. Then I also need to do my step 4, which essentially is telling me, are there any other common factors? Are there any other common factors between y and negative 4? No, we're totally set. So this is our final answer. Let's try a couple more problems. I'll have these steps written out on the top of every single one, so hopefully that'll help keep us on track. In this problem, we need to look for first our greatest common factor and factor it out. Is there any greatest common factor here? There's no x's in every single one. There's no 2's that can be factored out of every single one. So step 1 we cannot do. After that, we need to identify a perfect square trinomial or a difference of squares. We have a middle term, so it's not a difference of squares. As well, 2 is not a squared number, so it is not. Step 1 and step 2 are taken care of. We can't do anything there. Now we need to see if we can factor normally through guess and check or bottoms up. So let's try that. I'm going to make my big old X because I like to use bottoms up. I'm going to put a 5, my middle coefficient here, and then I'm going to take my first coefficient of 2, times it by 4, and I get 8. Now, what are factors of 8 that could potentially add to 5? We got 1 and 8, and 2 and 4. These don't add or subtract. They become either 7 or 9, and these become 6 or 2. So there's nothing that we can do for factoring. So that's taken care of. And we've already done step 1, which is almost the same thing as step 4. So this is final factored form. It is unfactorable. So you can write that down. It is unfactorable. It's taken care of. That's what happens sometimes, and that's okay. Let's try another problem. Here we go. Here are our steps. We need to find and factor our greatest common factor. Our step 1, if we look at this, I see that there is n's in every single one. It looks like there's actually an n squared that I can take out of every single one. It also looks like there's a 3 in every single term. So if I take out a 3n squared, I'll end up with 3n squared times n squared for my first term. Second term is going to be negative 5n, and third term is plus 4. Cool, that's awesome. So we've taken care of our GCF. Now we need to identify if there's a perfect square trinomial or not. So if we look at this, that can be turned into n times n. This can turn into 2 times 2. And this middle term needs to be 2 times n. So essentially our b term and our a term, b term and a term, multiplied by 2 and 4, that means it should be 4n, and it's not. So step 2 is taken care of, but let's see if we can factor it just with bottoms up. Let's see if we can do our number 3. So if, whoops, I didn't mean to do that, sorry. So if we're doing our number 3, we need to be able to do bottoms up with it. So we have our original equation, and our middle coefficient is 5. Our first term is, the coefficient on our first term is 1 times 4. 1 times 4 is 4. So what terms could add or subtract to be negative 5? We have 1, 2, and 4. Well, if I had a negative 1 and a negative 4, that could essentially add to be a negative 5, and they multiply to be a 1. And I'm going to put those over my first term, which is 1. So bottoms up says that the bottom number goes up in front, so 1n minus 1, and our other one is 1n minus 4. So now we've factored that, and we still have 3n squared. I just moved it to the back. I apologize. It's mainly because I ran out of space up at front. So step number 3 is taken care of, and our last little bit, look for any other common factors. So is there any other common factors here? We have a 1 and a 1, but that's really not going to change anything. And a 1 and a negative 4. Nope, we're done. So I'm going to rewrite this so I can really see it. Our final answer, I'm going to bring this back up in front because now I can put it there. And in all reality, everything's multiplying, so we can change the order of everything. That's okay. 3n squared times n minus 1. I just got rid of that 1 up in front because technically it can be invisible. And n minus 4. So that is our final answer. Now if we want to, we can actually do the multiplication and see if we can get back to our original equation, and let's do that really quick. So we'll do FOIL on our stuff. We'll do parentheses first, PEMDAS. So parentheses first says we need to do FOIL here, so we have 3n squared, which is going to be out in front. N times n is n squared. Inside terms, negative 4n. Outside terms, inside terms, negative 1n. And then we have a plus 4. So we have 3n squared times n squared minus 5n plus 4. And then we can take and distribute this 3n squared in. So we have 3n to the 4th minus 15n to the 3rd plus 12n squared. That, I do believe, is exactly what we started with. Same thing. So this original equation right here, this 3n squared times n minus 1 times n minus 4 is our factored version of our original equation. That's kind of cool. We did it. Let's try another. Find and factor out our GCF, and we have 4x to the 3rd plus 18x squared plus 20x, and it looks like our GCF could be at least, there's definitely an x in it. Also, what else could there be? It looks like there's 4, 18, and 20. The greatest common factor between those is a 2. I wish it were a 4. If this were a 16 for the 18, it could be a 4, but it's 18, so it's 2. So our GCF is 2x, so let's take out 2x out of every single term, and we will end up with 2x squared. 18 divided by 2 is 9, x divided by x is x, and then we have 20x, that ends up being 10. So there is our almost final answer. So we have taken care of our step 1. Our step 2, identify the perfect square trinomial or difference of squares. Perfect square trinomial tells me that this front term needs to be a squared number. 2 is not a squared number, so we already know it's not going to work. But let's also look at our back number. 10 is also not a squared number. So perfect square trinomial is not a possibility for us. So now let's actually just factor it normally through guess and check or bottoms up. I'm going to do bottoms up, and I'm only going to do the numbers that are inside. So we got 2 times 10, which is 20, and our middle coefficient is 9. So what numbers of 20? 2, 1, 2, 4, 5, 10, and 20. What of those numbers will add to be 9? Well, 4 and 5 will. So we have 4 plus 5. We're going to put that over 2, our first term. So 4 over 2, that can be simplified into 2 over 1. So, and 5 over 2 can't be simplified. So bottoms up tells us the bottom, what is in the bottom goes up in front. So we still have our 2x, and then we're going to have 1 plus, or whoops, I forgot my x. Need the x's there. 1x plus 2, and bottoms up, 2x plus 5. All right, so we've factored it, and now let's do our last step. We need to look for any other common factors. Are there any common factors between these two, x and 2? Nope. Are there any common factors between those two? Nope. So 2x times x plus 2 times 2x plus 5 is our final answer. One last problem, and this problem is my favorite, and I know I showed this one to you guys in class, and you're just so annoyed with me that I did because it's actually kind of difficult, but I really, really enjoy it, and there's ones like this all over in the world, and so we have to just deal with it. So first, let's look for our GCF. Our GCF, it looks like there is a p in each term, so we can take a p out, and we have p, whoops, that's not a p, that's an n. We have p to the 4th minus 1. So we've taken care of our GCF. Now we need to identify a perfect square trinomial or a difference of squares. And if I look at this, p to the 4th, that can break down into p squared times p squared, and 1 can break down into 1 times 1. So this is, and since there's no middle term, this is a difference of squares. Very specifically, that's a difference of squares. So if it's a difference of squares, we can essentially say we have p up in front. This breaks down into p squared times p squared, and this is 1 times 1, so we have p squared plus 1, and p squared minus 1. And if we were then to go on and say, okay, let's look at step 3 now, do we need to factor anymore? Do we need to do guess and check, bottoms up? And we look at it, like you might see, oh no, I'm good, I'm set, I've got everything taken care of. But I want to bring your attention to this baby. P squared minus 1. We can still do step 2 with this. We could also do bottoms up with it. We could do step 2 or step 3. So technically, this is not completely factored. So let's do one last little thing. Let's do a little bit more factorization. We have p times p squared plus 1. Finish that off. And then p squared can be broken down into p. And then minus 1 is either a plus 1, because this is a difference of squares, or p minus 1. And we are then at our final answer. So while this problem seemed to go on forever, they will eventually stop because p minus 1 cannot be factored anymore. There's not a squared term anywhere in the front term, so we're all set. But it will go on. So don't think that you're completely finished. I want you to be very careful of identifying all difference of squares, all perfect square trinomials. And if you don't get those, we can still do these with bottoms up. When you do bottoms up though, you'll have that middle term, and that middle term in this case is going to be a 0. And you're also going to find a negative 1. So what two numbers multiply to be negative 1, but add to be 0? Well, a 1 times a negative 1 would do that. And then you would come up with this sort of situation. So this can be factored with bottoms up, but you need to go through all of the steps. So let's go back up to the top, and if you have any questions, be sure to text me or call me, and I will be happy to answer them. I hope this helps, and enjoy your homework.